In this lecture, we are going to discuss multi-head attention. Previously, we focused on self-attention, where we were using only one head. Now, we will extend that concept to multi-head attention. Attention helps us understand how each word in an input sequence relates to the others. For example, we can identify how the word eat relates to end or open. Using a single self-attention mechanism works well for short sentences, such as pizza is good. But as sentences become longer, it becomes harder for a single attention head to capture all the patterns. This is where multi-head attention becomes useful. After encoding and positional coding, each word has a set of values, such as 2 encoded numbers per token. In multi-head attention, these encoded values are used to calculate separate query, key, and value sets for multiple attention heads. For instance, we can calculate one set of query, key, and value for the first head, another for the second head, and a third for the third head. Although each head generates multiple values, in the end we combine them so that the output maintains the same number of values per token as the original encoding. For example, if each word is represented by 2 numbers, the final output will also have 2 numbers. Each attention unit is called a head, and when we use multiple heads together, it is called multi-head attention. In the original transformer model, there were 8 attention heads, but the principle is the same regardless of the number of heads. After calculating the outputs for all heads, the results are combined to match the original dimension of the encoded token. If we reduce the number of attention heads, we can simplify the computation. For instance, if each token has 2 encoded numbers, we only need 2 attention heads to preserve these 2 values. Using more heads than needed is redundant, so we can remove extra heads to reduce complexity. In summary, multi-head attention allows the model to capture different relationships between words simultaneously. Each head learns a different aspect of these relationships, and their outputs are combined to maintain the original representation size. This approach improves the model's ability to understand complex input sequences. I hope this explanation clarifies what multi-head attention is and how it works.